All right, so welcome to your trig function or trig unit. Okay, this is 6.1 on angle measures. In trig, angles have special terminology. So this is an angle, like you guys all know, angle AOB. And the horizontal ray here is called your initial side. Okay, it will always be called your initial side, and you are always going to be using that horizontal as the start of your angle. Okay. And as you go up and draw out the angle itself, we're going to label this theta. All right. And then as you draw your other side of the angle of the other ray, right? It's called your terminal side because that's what's ending the angle. Okay. So terminal side, initial side, and you guys all know what vertex is. So theta, the angle itself, will always start with the initial side and go to the terminal side. All right. So if you move counterclockwise from your initial side, that's positive 30 degrees. If that's 30 degrees right there, right? And if you move clockwise through your initial side or from your initial side, then it's negative 30 degrees. So you're creating a negative angle when you're moving it counterclockwise or clockwise, and you're making a positive angle when you're moving it counterclockwise. Okay? And that's all in terms of degrees. But another unit of measure to measure out the degrees is called radians. Okay, so if a circle of radius 1 is drawn with the vertex at the center, then we can use radians to measure the angle. But what are radians? Imagine that this circle here has a radius of 1. Okay, so that's 1 unit, and that's 1 unit. Okay, so from here to here is 1, and here to here is 1. We are just measuring out the angle measure here. So this here is 1 radian. Okay, and also half the circle or 180 degrees of the circle is pi radians. So here in this picture tells us what the conversion rate is. If you're moving it from degrees to radians or radians to degrees, the relationship between radians and degrees is pi equals 1/8 or 180 degrees, 180 degrees equals pi. Okay? So if 180 degrees equals pi radians, what's 90 degrees equal to? Half of pi or pi over 2, right? How about 45 degrees? 1/3? Pi over 4, right? Because 180 divided by 4 equals 45. So you divide pi by 4 and get 1/4 or pi over 4. Okay. How about 60 degrees? What's the relationship between 180 and 60? Yeah. 60 is 1/3 of 180. So we're going to split pi into thirds. So pi over 3. Okay, how about 30? Same logic. 30 is 1/6 of 180. So that's pi over 6. Okay. It's really beneficial if you guys memorize these conversions. Okay. It will help you not just in this chapter, but in the next chapter, in the next 2 chapters, as we run through our trig unit. Okay. So now that we have that, we don't need to do this. Angles in standard position. If an angle is drawn in the XY coordinate plane, right, with x-axis and y-axis, and the vertex is at the center, the initial side is going to be the positive x-axis. Okay, the initial side of the angle is going to be the positive x-axis. Okay. So I drew an angle in standard position right here. The green is the initial side. The hot pink is your terminal side. The red dot is your vertex. And that is your angle, right? It's a positive angle because we're moving it counterclockwise. Okay. So if I wanted to graph, let's say, negative 130, I would start off with my green initial side, right? Right there. And go clockwise. I know that here is 90. If I go all the way around to the next line, I'm going to hit 180. So it has to be in my third quadrant, right? So it's right there. That's negative 130. Make sense? Yeah, I just graphed 130 in standard position. Okay? So if that is negative 130, what is this guy here? 200 something. You can go more exact. 240. 240? 230. Right? 230 degrees. Okay? What we just did, they are called coterminal angles. Why are they called coterminal angles? What does the prefix co mean? Together or share, right? Are the same, right? We're codependent. That means that we depend on each other, right? What other co words are there? Cooperate. We're working together, right? And terminal just means that terminal side. So they share that terminal side. That make sense? Yeah. That's what coterminal angles are. Okay. What if I wanted something that's greater than 360, like 660? Well, in this case, if I wanted 660 degrees, I'm gonna go one time around, that's 360, right? So 660 minus 360, that's 300. So I have 300 left over, correct? So from here, I'm gonna go around all the way to here. That is 660 degrees. That make sense? I just graphed 660 degrees. Okay. So a positive coterminal angle to 660 would be this angle here. And we already got that as 300 degrees, right? A negative coterminal angle would be this. What is that equal to in blue? 60, negative 60 degrees. Okay? So they are called coterminal angles because they share that terminal side. All right? And there's a definition right there. Okay? That makes sense? All right. Next idea is we are getting the length of the circular arc. Okay, so if we have a circle, class, let me draw it here. If we have a circle, like that, and I have a center, and if I say that's, I don't know, 7, right? The radius is 7. If I wanted to find the length of the circular arc of the whole thing here, I want to find the length of this guy here, correct? Now, this is not a difficult question. How do I figure that out? What's the formula we use? Huh? That is to find the area. 2 pi r. What is 2 pi r? What are we getting? Huh? The circumference, right? Yeah. So this, the circumference would be 2 pi times 7 or 14 pi, correct? But in terms of what we're doing in here, the length of the circular arc, so to find the length of the circle, we use circumference. Okay, or 2 pi r, right? To find the length of the circular arc, we just want that little part right here. From here to here, where you have your theta, you have your radius. Okay? So we want that little section of it, correct? Does that make sense? Yeah? So if theta is in terms of radians, what is the whole thing in terms of radians? 2 pi, right? That would represent the whole circle, correct? Yeah. So the formula here would be theta over 2 pi times the circumference of the circle. How does that work? Because theta over 2 pi is the ratio of that pizza slice. Does that make sense? Yeah. This guy over the whole thing is the ratio that we want. To get a better sense of it, I'm going to draw another circle. Okay. And I'm going to what's the ratio here? that's 90 degrees. Yeah. It's a fourth of it, correct? We all know that because it's 90, 90, 90, 90, right? So this is 1/4, correct? Or what I can say in terms of degrees, it would be 90 over 360. That is still the same, 1/4. Yeah? So if I have 5 here, right, as my radius, it will be 1/4 of the whole circumference, 2 pi times 5. Correct? We're doing the same thing in terms of radians. Theta over 2 pi is representing this part here is just representing this 1/4 here times the circumference of the circle, which is 2 pi r. Okay? We could also just say, if this was x in terms of degrees, it will just be x over 360 as well. If you wanted to leave it in terms of degrees, times the circumference of the circle. That makes sense? The reason why we use radians is because when we simplify this out, right? Instead of circumference of the circle, I use 2 pi r. These 2 pi's would cancel out. And you're left with pi times your radius. Right? So that little slice right there, S, the crust, is going to equal theta times your radius. So to find the length of the arc, S is going to equal r times theta. And your theta is in radians. Or if you wanted to leave it in terms of degrees, S is going to equal x degrees over 360 times 2 pi r. Okay? Cool. So we're going to use that information to figure out this example. The length of the arc of the circle, where we have the radius of 10 meters, subtends an angle of 30 degrees. So we want to find out what this is here. The crust, which is S. Right? Okay. So S equals r theta, where your theta is in radians. What is 30 degrees in terms of radians? Equals pi over 6 radians, right? So all we do here is go S equals 10 times pi over 6, which is 10 pi over 6, which would be 5 pi over 3. And that's your answer. All right, cool. So part B, it says a central angle theta in the circle of radius 4. So you have a radius of 4. Let me draw that out. You have a radius of 4 meters, and the arc is 6. Let's say this is and this part here is 6. Find the measure of theta in radians. So we want to figure out what this is, right? So remember, S is equal to R theta. So 6 is equal to 4 theta divided by 4 divided by 4. Your theta is equal to 6 over 4, or that would be 3 halves. Yeah. So if you just use that formula, you'll be fine. Okay. If you don't understand the formula, then you can always go back to x divided by 360 in terms of degrees times 2 pi r. Okay. Yes. This would be in meters. This would also be in meters. Or no, radians. Yeah. Yeah. No, the pi is already embedded in the 3 halves. If you don't see a pi, then that's fine.
So could you write 5/3 rad or different?
Well, that's different. Yeah. Just treat pi like a number, 3.14. Yeah.
When you're like, how do you when you use rad or when you use pi? Like in each scenario.
Here, the reason why we used pi is because our radian was in pi. Yeah. That's why there was a pi. Here, we had to figure out what our radian measure was, and it says 3 halves radians. Yeah. Okay. Same idea, different formula. Okay. The area of the sector now. We got to get the area of this. That means that we have to use the area formula, correct? Pi over or theta over 2 pi is the area or is the sector that we want times the area of the circle, right? In terms of degrees, it would be the area equals x degrees over 360 times pi r squared. Same thing. Okay, this one is in degrees. And then here, if you simplify this out, those pi's would cancel out, and you're just left with theta times r squared over 2. Actually, you know what? I'm going to move this down here. Oops. I didn't want to circle. Down here. Okay. So your area formula, in order to figure out the area of the sector, is going to be 1/2 theta r squared, where your theta is in radians. And if you want it in terms of degrees, it would be x degrees over 360 times pi r squared. Yes. This part here. Because if this was theta, if this angle here was theta, the whole thing is 2 pi in terms of radians, right? So then it would just, the ratio that we want or that we're interested in is theta, this part here, over the whole thing. Yeah. Okay. Cool. So if we figure out 63, part A, it's in terms of degrees. So just leave it in terms of degrees then. 80 divided by 360, that's the area, that's the ratio of the circle that we want, right? 80 degrees and the whole thing is 360 times pi r squared, which is 8 squared. So this would be 8/36. I can simplify that more, times 64 pi. 8/36 can both go into 4. So it'd be 2/9 times 64 pi, which is 128 pi over 9. And then, no, there is no units. So that'll just be your answer. All right. Part B, we have 0.5 radians. So we're going to use the formula of 1/2 theta r squared. So your area is going to be 1/2 times 1/2, which is 0.5, times 10 squared, which is 100 over 4, which is 25. So the area of that little sector is 25, whatever your units would be. Yes. On the what? Yeah, so this one's in radians. This one's in degrees. Yeah. So we used basically the formula for degrees or for radians. You can use either or. Okay. Any other questions here? Pretty simple. Yeah. That is your lesson, class, for today. And that was